All right, let's jump right into this explainer and look at the absolute foundation of our physical world. Every single time you check your phone for the time, or weigh out ingredients for dinner, or even just feel the warmth of your morning coffee, you are actually interacting with an incredibly complex, intricately designed structure. If we really want to understand how this universe works, we kind of have to look at its underlying rules, like a massive 3D architectural blueprint. Literally every single thing we observe, every physical phenomenon we interact with, is built upon a very specific, carefully engineered foundation. So today, we're going to explore the core framework of reality, the 7 pillars of physical measurement.
Everything we measure in the cosmos, from those unimaginably tiny subatomic particles all the way up to grand swirling galaxies, is built upon exactly 7 fundamental pillars. Honestly, it's a shockingly small number when you stop and think about the infinite complexity of the universe. Just 7 core 3D blocks that govern everything we know.
So, here is the blueprint for our explainer today. 1. Why exactly 7? 2. Independent by design. 3. Covering all of physics. 4. Building complex measurements. And 5. Expanding the foundation. Let's get to it.
Section 1. Why exactly 7?
Now, when people hear that there are exactly 7 fundamental units, the immediate assumption is usually that this is some unbreakable cosmic law. The big question we have to ask is, did nature force the number 7? Like, did the universe hand us this exact, rigid 3D blueprint and say, hey, this is it? Well, that's actually a super common misconception. The truth is, the universe didn't magically mandate this number at all. There's no hidden cosmological constant out there screaming the number 7. Rather, scientists made a very deliberate, calculated choice.
We use 7 because it is the perfect, practical toolkit. It was designed by scientists to cleanly capture every single measurement in physics. Think of these 7 units as the ultimate set of foundational 3D building blocks. We basically needed a set of tools that was small enough to be manageable, but robust enough to describe absolutely every physical event. It's a massive triumph of human engineering and logic applied to the natural world.
Section 2. Independent by design.
So, the defining feature of a base unit is that it is entirely self-sufficient. Absolutely none of the units can be expressed in terms of the others. I want you to visualize these as solid, completely distinct 3D blocks in our architectural model. You cannot break one down and rebuild it using the pieces of another. A length block is purely a length block. A mass block is just a mass block. They share absolutely no common geometry.
For instance, you just cannot define time using only length and mass. No matter how you stack those length and mass blocks together, no matter how complex the 3D structure you build out of them gets, they will never ever equal time. Time is its own fundamental dimension, requiring its own distinct load-bearing pillar. This mutual independence is what ensures there's zero redundancy in our foundation. Every single block does a job that no other block can do.
Section 3, covering all of physics.
What's brilliant here is how this elegant framework assigns a specific pillar, or sometimes a small group of pillars, to every major scientific domain. When we're dealing with mechanics, the movement of physical objects, we rely on length, mass, and time. When we shift our focus to the spark of electricity, we bring in the pillar of electrical current. For the blazing heat of a roaring engine, we use temperature. For the intricate, molecular 3D world of chemistry, we have the amount of substance. And finally, for the dazzling visual world of light, we use luminous intensity.
Together, these 7 stand side by side. They are perfectly spaced to carry the weight of all scientific measurement. It is just an incredibly clean system. There isn't a single physical phenomenon we can observe in the universe that cannot be traced right down to the floor of this framework, completely grounding itself in one or more of these 7 pillars.
Section 4. Building complex measurements.
Okay, so everything else in physics is simply a superstructure created by snapping these base blocks together into what we call derived units. It's like a giant puzzle. Take velocity, for example. It isn't a fundamental pillar, it's just a length block divided by a time block. Force? That's just a mass block multiplied by acceleration, and hey, acceleration itself is just length divided by time squared. And energy? Well, that's a mass block multiplied by a length block divided by a time block all squared. You can clearly see how we're stacking these foundational 3D pieces together to create incredibly complex, multidimensional concepts.
The profound takeaway here is that every single complex measurement is built directly from the foundation of those 7 base units.
Whether you're measuring the incredible thrust of a spacecraft leaving the atmosphere, the delicate energy output of a lithium-ion battery, or the crushing, precise pressure at the pitch-black bottom of the Mariana Trench, you are simply combining those original 7 foundational pillars in different configurations. The whole shebang comes back to the base blocks.
Section 5. Expanding the foundation.
Now, early scientists actually tried to build everything with a much smaller toolkit. In the earlier days of physics, the foundation was built with just 3 blocks: length, mass, and time. And for a while, that totally worked. If you're just studying basic gravity, planetary orbits, or, falling apples, those 3 blocks are entirely sufficient. But as human curiosity and scientific capability grew, we quickly realized our foundational floor plan was just way too small.
As we push the boundaries of human knowledge, discovering the invisible forces of electricity, the complex rules of thermodynamics, and the deep submolecular interactions of chemistry, the old 3-pillar foundation literally started to crack under the weight. To support these heavy new structures, we had to renovate the blueprint of science. We systematically added 4 more load-bearing pillars: current, temperature, amount of substance, and luminous intensity. We did this to achieve absolute clarity and to keep the math elegant and functional.
Which brings us to a really fascinating final thought. We know that nature didn't force the number 7. We chose it because it perfectly maps the boundaries of physics as we currently understand it. But human knowledge is never truly finished, right? As we probe deeper into quantum mechanics, dark matter, or perhaps dimensions we haven't even conceived of yet, if we unlock entirely new, unmapped realms of the physical universe, will our 3D blueprint eventually require the addition of an 8th block? I'll leave you to ponder that one. Thanks for joining me on this